So a little bonus material for section 3.7. We're going to look at polynomial and rational inequalities. This one is a real nice one to start out with because it's already set up. You've got it factored. You've got 0 on one side. That's perfect. We need to know where it equals 0 first, and I'm hoping you can actually read off those numbers from left to right. So what places would this cross the x-axis? If you were to graph this as, say, p of x equals that. 1, negative 5, 6, and negative 9. Perfect. Let's put those in order on the x-axis, and thanks for that. So it's going to be negative 9, negative 5, 1, and 6. Now that breaks up the real number line into intervals. So let's look at those intervals. That's going to be negative infinity to negative 9, negative 9 to negative 5, negative 5 to 1, 1 to 6, and 6 to infinity. And we've got to test points in each of these intervals. So I need some test points in here, 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 and here. I want to find out where this is greater than or equal to 0. So how about some test points? Any suggestions?
Negative 10.
Negative 10.
Negative 7.
Negative 7.
0.
0 is always a good one.
4. And 7.
Excellent, excellent. So those are our test points. Now you can test that either in Desmos or in your graphing calculator. I happen to have this one already plugged into my graphing calculator. So here it is here. As a reminder, you want table setup like we always do to ask. So you hit second and window, make sure this is at ask, dependent is at auto, and you hit second and then the graph key. If there's some stuff here, you can get rid of that, but we're going to do our own table. We're going to plug in your suggestions for our test points: negative 10, negative 7, 0, 4, and 7. Now we're not really interested in the fact that if you plug in a negative 10 in the function, you get 880, or that negative 7 gives me negative 416. What we're interested in is the sign of this stuff. Is it positive? Is it negative? What did we get? And in this case, things alternated very nicely. It was positive, negative, then positive again. So plus, minus, plus, minus, plus. Which intervals do we want? Do we want the positive intervals or do we want the negative intervals? We want the positive ones. Good. So that means I want this one, and this one. But now we pay a little bit more attention to the fact that this is greater than or equal to 0. And so if you were to look back here and plug in, say, a negative 9, negative 9 gives me 0. Well, 0 is greater than or equal to, it's the equal to part, 0. So I can include that, and notational wise, I can include that by using what kind of notation? The bracket, good. So we want brackets around that. Likewise, I want brackets around all these finite numbers. Negative 5 and 11 get a bracket. And then 6 gets a bracket. Infinity and negative infinity get a parenthesis. So looking great there. Wonderful. That's our answer. All done. Comments on that one? Yes?
We made a mistake. It's supposed to be 1, not 11.
Yeah, you're right. Thank you so much. So, little magic here.
Wow.
Beautiful.
How did you
Beautiful.
do that?
It's a 1. Yep. Yeah, you're right. That should have been a 1. Appreciate that. Now, quite often these things will alternate, and with polynomials you can actually kind of see that based on the graph. So if you follow the link I showed you, you can see that to the left of negative 9, the graph is above the x-axis, it's positive. Between -9 and -5, it's below the x-axis. And then between -5 and 1, positive, negative, positive. So we can see this pretty clearly looking at the graph. The problem that you're going to face is that it takes a little bit of skill to get the graph scaled to what you might want. For instance, this is what the graph looked like when I first graphed it. Wow. So, yeah, you're probably better off just looking at the numbers and saying, okay, positive, negative, I want the positive, I want the negatives, depending on the problem. So let's keep going with example B. So for example B, we've got x plus 8 squared times x plus 3 times x minus 1. Want that to be greater than, or no, just greater than 0. So, all right, x plus 8 squared times x plus 3 times x minus 1. So this is example B. And I want to know where that's greater than 0. Well, we'll start off kind of the same way we did the last one. And that is, I need to figure out where this is actually equal to 0 first. And because this is already factored, and I've got 0 on one side, I'm hoping that you can just read off these points. Where could this polynomial actually equal 0? Maybe I'll call that s of x. -8, -3, and 1. Beautiful. And once again, you get intervals along the x-axis. In this case, -infinity to -8, -8 to -3, and -3 to 1, and 1 to infinity. Okay. I need test points like I did before.
-9,
Good.
-5.
Keep going.
0 and 2.
-9, -5, 0, and 2. I always like 0. It's just a friendly test point. So good job on those. Let's go back and plug those into our calculator. Now, I've already got that. Actually, I don't. I'm going to shut this graph off. You know, I think I can just clear that out altogether. Let's just clear that out. And type in the function, parentheses, x plus 8, parentheses. Then hit the squared key on the left-hand side. And x plus 3, parentheses, another parentheses, x minus 1. And let's go with your test points. So second, and then the graph to get us to the table. Let's just delete all these and type in ours. -9, -5, 0, and 2. Now, unlike the last example, it goes positive, positive, negative, positive. And that's something I want to look back at, because oftentimes they alternate positive, negative, positive, negative. Not always, though. So positive, positive, negative, positive. So, okay, cool. Which interval or intervals do I want? Well, I want the positive ones. So that would be negative infinity to -8 union -8 to -3 union again 1 to infinity. And that's fine like that. Yes?
I always wonder, is there a reason you can't just go from -infinity to -3? Or is that like illegal?
It's a great question. And it's a great question. So why can't I just go from -infinity to -3? Because that would be including the -8. But let's see what happens at -8. In fact, let's put it in. -8 is an endpoint for us, so it's a great question. Let's put in -8, and I get 0.
Oh, it's not equal.
Is 0 greater than 0? It's
equal
not.
to
It's
0.
equal to 0. So if this question was a little bit different, so this is for s of x greater than 0. If I did s of x greater than or equal to 0, that would change things up, because then I could use the -8.
Okay.
So I'll show you this two ways. A lot of people might go, all right, negative infinity to -8, include that, because you can include that now, and then -8 to -3, bracket there, union 1 to infinity. But if you look at this really carefully, it's just what you said. You've got everything between negative infinity and -3.
Okay.
So I'd be happier grading this if somebody would write negative infinity to -3, like that. Just kind of combining these two into one. Of course, this one is still here, but yeah, that's a great question. Yeah, it makes a big difference if you have a greater than or equal to here.
Yeah, okay.
Nice. All right, let's keep going unless there's some more comments or thoughts here. I'm going to speed a little bit of this up because I'm hoping that you can do things like the quadratic formula on your own. I know. Let's just hope so, though. So the next one is example C. I want to know where this rational inequality is less than or equal to 0. So x over x squared plus 2x minus 5 is less than or equal to 0. Now I got to find a couple types of points. I got to find where the numerator equals 0. Well, that's pretty easy, right? That's just x equals 0. But what about the denominator equaling 0? That, you're going to have to trot out the quadratic formula. X squared plus 2x minus 5 equals 0. And I'm going to jump to the happy ending for us here. That's going to be -1 plus or minus the square root of 6. So, wow. All right. A lot going on there. So that puts a total of 3 points on your x-axis. 1 here, 2 here. We've got 1 down here at -1 minus the square root of 6. Another one at 0, and one at -1 plus the square root of 6. So, wow. Again, not all that easy to deal with. It might be helpful to have some decimal values that go with these things so that you know where to test your points. The reason I mention that is because a lot of times people get a little bit confused. They're like, well, wait a minute, what's to the left of this? What's to the right of this? So here's your values. One is about -1.45. It's about -1.45. The other one is positive. Excuse me. One of them is -3.45. The other one's positive 1.45, approximately. And the only reason I put this out there is because you need to come up with test points in between here so that you hit the right intervals. So I need a test point here, 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 and here. It's a lot easier to do looking at a decimal value than it is looking at something else. -4, -2, 1, and 3. There we go. Those are good test values. You could test this in Desmos. You could test this on the graphing calculator. It doesn't matter. I do have this one programmed in our graphing calculator. Let me get over to there. I'm going to shut this graph off by pressing the Enter key with my cursor on the equal sign, and turn this graph on by doing the opposite. So press Enter. It's now highlighted. Notice that in typing this one in, I need to put parentheses around the entire denominator. Now clear that. Let's go to the table function, delete all the old values, and then type on our new ones. -4, -2, 1, and 3. Now the information I need out of here is not that I get -4/3 when I type in a 4, but I get something negative. And it's alternating just like a lot of these do. Negative, positive, negative, positive. So let's take a look at that. Negative, positive, negative, positive. Let's get rid of this so it doesn't look confusing. There. Which ones do I want in this case? Do I want the negative intervals or the positive intervals?
Negative.
Negative, yay. All right, so I want this one and this one. That's going to mean I want negative infinity to -1 minus the square root of 6, and then 0 to -1 plus the square root of 6. Now, if you're not sure about the endpoints, you can type those in and find out for yourself. For instance, can I use a 0? If you type in a 0, well, 0 is less than or equal to 0, so you're okay there. How about the other two endpoints? I could type in -1 minus the square root of 6, and uh-oh, it's undefined. Why is it undefined? Did I make a mistake? No, I did not make a mistake. It's undefined because these are the points that make the denominator 0. So it makes sense that it's undefined here. What that means for us here is a parenthesis here, parenthesis here. How about a 0?
A bracket?
A bracket, because you can use a 0. You can plug in a 0, you'd end up with 0 divided by -5, which is 0. And 0 is less than or equal to 0, so we're okay there. Whew. All right, last one coming up. It's just a little different than some of the other stuff, so let me hit that here real quick. Example D, we want to know where f of x, which is 49x, is greater than g of x, which is 1 over x. So the short story about this is, where is 49x greater than 1 over x? That's your inequality. Our work is not set up to solve these inequalities like this. First thing we need to do is get 0 on one side, which, all right, that's not that bad. But the second thing I need to do does take a little bit more work. I need to write this with one rational expression. So that means I need to multiply this by something so that I have a common denominator. And that something is x over x. So that gives me 49x squared over x minus 1 over x is greater than 0. Since these have a common denominator, I'll bring together their numerators. 49x squared minus 1 over x is greater than 0. And now it's a matter of finding out, well, where's the numerator equal 0? That's where 49x squared equals 1, x squared equals 1/49, or x equals plus or minus 1/7. Remember, there's two roots there. The denominator equals 0. I'm hoping that that's pretty clear. So you've got 1, 2, 3 points to do out your number line. I'm going to squeeze that in here. negative 1/7, 0, and 1/7. You're going to take and plug in test points into this expression right here. The one that has 0 on one side. Test points here. Now, as far as this problem is concerned, you don't necessarily have to do it in this function. You could do it in this one. That'd be equivalent. I don't know. I just feel compelled to do it there, but it's up to you. But that's where you want to put your test points. Our test points have to be things in between each of these. So that's going to be a little bit of work for you because, well, you're going to have to come up with some fraction or decimal that's between 0 and 1/7. 0.1 will work, just saying. I actually have that one graphed. I actually had the last one graphed. If you look, those 2 points that where the denominator was 0 are actually our vertical asymptotes. So let me just shut those off. Let's take a look at this one. Again, the problem that you're going to face with these things is that the graphs are ugly. I suggest you just work them with your graphing calculator and not worry about the graphs. If you want to spend time with the graphs, you can figure out that, okay, yeah, I see what's going on here, but it takes a little bit of skill. So you can see that, for instance, if x is greater than 1/7, greater than or equal to 1/7, along the orange portion of the x-axis, then the graph is positive. There's also another little region where the graph is above the x-axis. It's not between 0 and 1/7. It's between negative 0, or excuse me, negative 1/7 and 0. That little portion right here. So if you're testing out points, it goes negative, positive, negative, positive. There's a way to test out. And I apologize for not taking time here, but I want to get you busy on your homework. Negative, positive, negative, positive. If you're looking for the positive intervals, it's these two right here. So your final answer would be, you can include the negative 1/7. So negative 1/7. Can't include the 0, and then 1/7 to infinity. So that would be your final answer on that one. Cool. All right. Comments or thoughts on this one?
And why can you include the 1/7 again?
Because 1/7 makes the numerator 0. Oh, you know what? This is greater than 0. I'm sorry, we can't include the 1/7. That would be a parenthesis. Yeah. So that's nice. If it's greater than or less than, then everything's parentheses. Yeah. If it's greater than or equal to or less than or equal to, then you got to start thinking. But yeah, thanks for that. Say again?
There's a union between negative 170 and 170, right?
Yes.
Okay.
Union there.
Sure. Thank you.
Thank you. Thank you. And let's try and make that a little bit more legible. 1/7. Beautiful. All set? Anything else? All right. Good luck on this.